Hello student, welcome to the class of Computer Network. I hope that you have watched my previous video related to Computer Network. In today's lecture, we will be studying about OSI model, its layer, characteristic and functions. So let's get started. First, we need to study about what is the need of OSI model. Why do we need such model in our networking? So let us begin. OSI is for Open System Interconnection. Open System Interconnection, and it was developed by ISO, that is International Organization for Standardization. Now, the main purpose of this OSI model is interoperability. What do you understand by the word interoperability? Means, as we know that the computers are from different vendors, the software are from different vendors. Still, if node A is going to communicate with node B, and both node A and node B are from different manufacturer, they will be using different architecture. Still, node A should be able to communicate with node B. So over here, we are going to interoperate between two different nodes, between two different set of hardwares and softwares, not only two, n numbers, because between node A and B there can be n number of nodes. So the data should pass correctly from node A to node B. So we require one kind of model through which we are able to communicate between different nodes. So for that purpose you require some set of protocols, some kind of architecture. So that is nothing but the model was developed, that is the OSI model. Now this OSI model divide the whole task of sending a message from node A to node B into several smaller and manageable tasks. So over here in a OSI model there are 7 layers, and each layer is going to perform some task. So you can say that each layer is self-contained, means each layer is going to perform some independent task, and your OSI layer are divided into two categories. You can say the model itself is divided into two layers, that are the upper layers and the lower layers. Upper layers are closer to the application. It is closer to the application related issues, and application are closer to the end user, whereas the lower layer are the or one which deal with the data transport issue, like your lower layers means your data link layer, your physical layer. Each layer is going to perform some kind of task, and they are independent. So we'll study which are the various layers which are present. So various layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So physical layer is your layer 1. Now each layer is going to perform some task. There are various protocols that work at each layer. So one by one we'll study what is the function of each layer. So we will start with a layer 1, that is the physical layer. Let's start with the first layer of OSI model, that is the physical layer. Now what is the physical layer? Physical layer deals with the transmission of raw data between the nodes. So you can say that physical layer helps you to define electrical and physical specification. Electrical and physical specification of the data connection. Now it is responsible for actually transmitting the data in the form of bits, in the form of analog signal. So you can say that it is responsible for transmitting individual bit from one node to another. As you can see from this diagram, that physical layer is the lower layer. It can be also be called as the hardware layer or the lower layer, and it deals with the transmission of the raw data. So it helps you to define electrical and physical specification. How much will be considered as a 1, how much will be considered as a 0. That is the electrical and the physical specification can be understood by the physical layer. The hardware that work at the physical layer are the adapters, Ethernet, repeater. So whatever data it is going to receive from the data link layer, it will convert it to a zeros and one, and then it will transmit it across the transmission media to the next node. The transmission media can be guided, it can be unguided, depending upon your network. So you have to remember that it deals with the electrical and physical specification, it deals with the transmission of raw data, it contains information in the form of bits, and the hardware that work at the physical layer. Such question you can get, which kind of hardware work at the physical layer, you can get in any of your competitive exam. So next we'll study are the functions. What are the functions of the physical layer? So there are many of the functions of the physical layer. So I have divided into two parts. So first we'll study about first, that is a function of the physical layer according to the topologies, configuration and transmission mode. So as you know that what is topology. So physical layer defines the way the different computing devices in the network must be arranged with each other. So there are different topologies, that is bus topology, star topology. I have made my videos, lectures related to topologies, so you can watch it. So physical layer defines the way how different computing devices in the network must be arranged with each other. There are various topologies, the way in which the nodes are connected. Next, the physical layer deals with the configuration, whether the communication is point to point, whether it is multi-point configuration. So what do you understand by point to point? In point to point, there is a dedicated link between the two nodes, whereas in the multi-point configuration, a single link is shared among the various computing devices. As you can see, this is the shared link which is used by all these nodes. So this is the multi-point configuration. As there is a dedicated link between two systems, this is the point-to-point configuration. So first it deals with topologies, how different computing devices in the network are arranged. Next is the configuration, and next is the transmission mode, how the data is passed. It defines the direction of transmission between two devices. So it can be simplex, half duplex and full duplex. In simplex, the direction of data flow is only in the one direction. For example, uh, if you are controlling the channel using the remote control, you are controlling the channel of the TV using remote control, data move in only one direction. Next is in the both the direction, but only one at a time. So you can just think about the railway lines. The track is used to take a train from one direction to another direction and vice versa, but only one at a time. And next is the full duplex. The data move in both the direction all the time. That is the full duplex communication. So all this transmission mode, configuration, topologies, all these are taken care by the physical layer. Next, in depth about the function of the physical layer can be divided as the hardware layer, bit synchronization, bitrate control, baseband and broadband transmission. So hardware layer, why we are calling it as a hardware layer? Because it deals with the setting of the physical connection to the network. So we are calling it as a hardware layer. What is the bit synchronization? Bit synchronization means sender and receiver are going to synchronize at the bit level, so that they are able to pass the information. So there are some kind of clock controls which deals with the sending and receiving of the bit. Next is the bit rate control. That is how much bit should be passed per second from sender to receiver. It should not overwhelm the receiver. neither it should be very slow. So that is a bit rate control. Next is the baseband and broadband transmission. So what do you understand by the baseband transmission? So baseband transmit the digital signal using the physical medium like wires. Okay, it transmit the digital signal. Baseband transmit the digital signal, whereas the broadband transmit the analog signal. So you can see over here, baseband transmit the digital signal and broadband transmit the analog signal. So you can say what are the function of the physical layer. It deals with the topology, it deals with the configurations, it deals with the mode of transmission, it deals with the hardware layer, it synchronizes the bit, it controls the bit rate, it is going to control the bit rate, and it deal with the, means it decide whether the data should be passed in a digital mode or whether the data should be passed in analog mode. Everything is decided by the physical layer of the OSI model. So this is all about the physical layer. Next we'll study about the data link layer. Next layer is the layer 2 of the OSI model, that is a data link layer. What is a data link layer? Data link layer is responsible for node to node delivery of message. You have to remember that data link layer is responsible for node to node. What do you understand by the word node to node? Now if sender wants to send a message from node A to node B, so there can be n number of nodes between them, n number of computers between them. Now this data link layer is responsible for node to node delivery. Means if the message is moving from one node to another node, then it is moving from this node to another node, then it is moving from this node to the receiver. The data should not be corrupted as it moves from node to node, because if the data is corrupted as it moves from node to node, ultimately the data which is received at the receiver end will be corrupted. So data link layer is responsible for the correct delivery of message between node to node. So the main function of this layer is to make sure that data transfer is error free from one node to another node over the physical layer. When a packet arrives in the network, whenever a packet arrives in the network, it is a responsibility of the data link layer to transmit it to the host using the MAC address. If the data is received in the network, okay, some network is there, and if data is received in the network, and in the network the data should move to the correct receiver. How it is been done? It is the responsibility of data link layer. It transmits to the correct host using the MAC address. So you can say that data link layer is divided into two sub-layers, that is a logical link control and media access control. Now, whenever this packet is received in a network layer, I will emphasize on this point, that is whenever a packet is received in the network, it is the responsibility of the data link layer to transmit it to the host using the MAC address. So, when the packet is received from the network layer, it is further divided into frames, and this frame size will be decided by your network interface card. The data link layer is going to encapsulate the sender and receiver MAC address in the header. The data link layer is going to put the sender and receiver MAC address. MAC address is a special kind of physical address which is embedded on your NIC card. So it is going to encapsulate the sender and receiver MAC address. The receiver MAC address is obtained by using one of the protocol, that is ARP, that is the address resolution protocol. So when the message is received from the higher level, that is from the network layer, that is a packet. Okay, in network layer we call the message as a packet. If packet is received by the data link layer is going to encapsulate using the sender and receiver's MAC address. That is why we are saying that when the packet arrives in the network, after moving across the node to node, node to node, node to node, and finally it arrives to the network. Now the data link layer, the work of data link layer come into action. It transmit it to the correct host using the MAC address, because as you will see in addressing mode, n number of computer will use one address, and then the correct message will be passed across the nodes. So how it will be done? It will be done using the data link layer. So there one interesting diagram is there over here, that is from node A to node B. So the data link layer is going to deal with the node to node delivery, from one node to another node, one another node to another node. Then there is a host to host delivery, and there is a process to process delivery. Host to host means from one host to another host, and even after reaching the correct host, it should be delivered to the correct process. So that is the process to process delivery. So what is the function of this data link layer? The function of this data link layer is framing, physical addressing, error control, flow control, and access control. So framing means whatever the data is received from the network layer, it puts the MAC address of the sender and receiver. So framing is a function of a data link layer. So it provides a way for sender to transmit a set of bits that are meaningful to the receiver. That is, it is accomplished by attaching some kind of special bit pattern at the beginning and end of the frame. So over here in the data link layer, whatever message is there, we'll call that message as the frames. So frames will be passed to the lower layer, and then frames will be received by the physical layer, and it will divide it to the bits pattern. So concept of framing comes under the data link layer. Next is, after creating the frames, it will add the, as we have already seen, after creating the frames, it will encapsulate using the physical address of the sender and the receiver. Next is the error control. Now whatever error control mechanism is there, because if data is moving from one node to another, then there can be some kind of damage in the bits via the any of the reason. So because of noise and whatever reason, there can be error in the data bits. So data link layer provides the mechanism of error control, in which it detects and transmits the damage or the lost frame. So there are various error control mechanisms that we'll study in a further lecture. Okay, you just have to remember that it deals with the error control which is node to node. It deals with the error control which is node to node. Next is the flow control. Flow control means amount of data that needs to be passed to the receiver before waiting for an acknowledgement. That is the flow control. Now it will not send one data, it will wait for the acknowledgement. It will be a very slow process. So you require some kind of flow control mechanism. There are various flow control mechanisms that we'll study in a further lecture. And next is the access control. Access control means if n number of device wants to use some channel, so how they are going to access that media, that comes under the access control. So when a single communication channel is shared by multiple devices, the media access control deals with the method to determine who will access the channel for what amount of time. So that is the function of the data link layer. What is the function of data link layer? Framing. It divides the packets, whatever it receives from the network, to a frame. Then it add or it encapsulate the MAC address of the sender and receiver. Then it deals with the error control mechanism, so that the correct message is from one node to another. Next is the flow control mechanism. That is the amount of data that needs to be passed, and the access control. That is, if multiple devices wants to access a channel, there should not be any kind of collision. So for that, there is a media access control mechanism. So all these functions are taken care by the data link layer. So you can see that whatever packet that is received from the network layer, The data link layer is going to add the header and the trailer to form a frame. And this is the MAC address. A MAC address is the unique address which is embedded on your NIC. It is again been divided into two subparts. That is the organizationally unique identifier and network interface controller. So in today's lecture, we have studied about what is the need of OSI model, what is the function of the first layer, that is a physical layer, how it is going to work, and next we have studied about the data link layer and what are the functionality of the data link layer. So I hope that you have understood my lecture. Thank you for watching the lecture. If you like my lecture, kindly like, share and subscribe to my channel. And in the further upcoming lectures, we'll study about the other layers of the OSI model. Thank you.